Hello, students. Welcome to lesson 11. So we're going to talk about constant rate. So we learned a little bit about constant rate last time. We're going to get a little more deep into it. We know the definition of constant rate in various contexts. Distance equals rate times time. The constant rate, I'm always traveling at the same speed. Distance just comes about when I multiply that speed times however long I traveled. Okay, and if I have the distance, then I can divide by that constant rate and equal the time. Okay, t is a time interval. So we can graph these on a coordinate plane and relate it to constant rate problems. Relate it to proportions is what they're saying. So if I graph all of these, they will always be a straight line. So let's take a look. A constant rate is stated for a given problem, then you can express the situation as a two-variable equation. The equation can be used to complete a table of values that can be graphed on a coordinate plane. So remember, our two-variable equation is when we have two variables. Y over x equals our constant rate. Our distance equals our rate times the time, where rate is always the same number. Distance and time can change. Okay, so that's what we're talking about when we have two variables. So we'll move on and take a look at our first example. Pauline mows a lawn at a constant rate. See, it says constant rate in there, so we know she's not going faster or slower. She's always mowing the lawn at the same speed. She mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? Can she mow in t minutes? So this is pretty easy for 10 minutes. So if it's 2.5 minutes, 35 square feet, if I double 2.5, 5 minutes, she mows 70 square feet. So if I double that again, then in 10 minutes, that will be 140 square feet of lawn. Square feet. That's great for this, but what about t? So in any time, so if I can say, hey, I mowed for 4 hours, how much grass did I cover? Because I'm only working 4 hours today and my grass is so big, I want to know how much, if I can cut the whole grass in that many hours. Okay? So we're going to make y represent the number of square feet, and t is t, just to confuse people. So instead of x, we're using a t, and y is the distance. So the distance equals rate times time. So take a look at our standard equation. Distance equals rate times time, or this y is t times something. Okay? Find out what that something is. Y divided by t, because we were told it's a constant relationship, a constant speed she's mowing at. So if I do 35 divided by 2.5, that's a distance divided by the time. Multiply both sides by 2.5 and by t from the lesson. The other, when we have these proportions, we multiply by the denominator, 2.5 and t on both sides. 2.5 and t. T cancels out here. 2.5 cancels out here. I have y times 2.5, and I have 35 times t. I don't know why I switched them around, but then I divide by 2.5 on both sides, so 2.5 cancels out. 35 divided by 2.5. I don't even mess around. If any time I see this and I say you're doing a constant speed, x and y, then my constant is y divided by x, just like any other proportion. And until I actually need that, I don't even need to divide that. But if I want to, I can put that in my calculator, 35 divided by 2.5, and I get a constant rate of 14. So y equals 14t. So that would be square feet. So in 1 minute, 14 square feet of yard is mowed. Okay, so y equals 1 minute, 14. So our rate is 14 square feet of yard mowed in every minute. All right, so our table could be right here. 0 minutes, 0 feet cut, right? Didn't cut anything. In 1 minute, 35 divided by 2.5, 14 square feet. In 2 minutes, 28 square feet. 3 minutes, 42. 4 minutes, 56. All the way up to 10 would be 140 square feet. Okay. If I graph it, if I put it in Desmos and I put in the equation that we just did, right? Distance y equals x times 14. If I could write it that way, I could write x 14 equals y in Desmos. I think that'll work. But they usually write it as y equals 14x. This is the standard form that people expect to see. It works for sure, and it would give me this graph, this straight line. This stuff here I wrote in extra, and I had to adjust it to make it look pretty, but that's all. Okay, so let's take another. If I graphed it, I would put it on here, and every time I go over 1, I go up 14. Over 1, go up 14. That's called the slope of this line. Every time I go over 1, I go up 14. Okay. All right. So average speed and constant rates. A special case of a larger problem called the constant rate problems. Define the average by dividing amount by time. That is our constant rate. Y divided by x equals our constant. So in words, we would describe it as she can mow 35 square feet of lawn in 2.5 minutes. The constant rate is she can mow 14 square feet of lawn per minute. The average amount over a specific time is the constant over a unit of rate or time. Okay. Lesson 11 practice. Answers will be later in the slide deck if you want to look at the answers. And then so in lesson 11, we know that the definition of constant rate varies in context. So the constant rate can be different for each problem, but it's expressed as two variables, y divided by x, or y divided by time, or distance divided by time. Or if you see distance equals rate times time. And we can graph each of those points on a coordinate plane, and those points will go up or down in a regular constant rate. The constant rate is stated for a given problem. Then you express the situation as a two-variable expression. Y over x equals the constant, or distance equals the constant times the rate, times the time.